Hello everyone. In this video we will learn what is a circular permutation and how we count number of circular permutations of k or n different objects. Okay, so to start with, let me recall that so far what we have been studying was linear permutations. In other words, what we were considering was that there was a line of objects. Now we want to study circular one, meaning that our objects are not going to be lined up. They are going to be placed symmetrically on a circle. What is the difference between linear and circular permutation? First of all, both of them are permutation. There are some ordering there, like there's left and right makes sense for each person there, yes. But what makes the difference is that you see in the linear permutation, the first and last objects are there. There are first and last object. However, in this one, there is no, in the circular one, there's no first and last object. Yes, so basically we kind of get rid of that first and last, and that's how we get circular permutation. Okay, so there are definitely differences, but how we are going to count the number of circular permutations? Well, let us just quickly see an example. Let's say I have three objects A, B, C. So A, B, C, then I can have C, A, B, then I can have B, C, A, then I can have A, C, B. These are the linear ones, yes? A, okay, and then B, A, and then C, and the last one, there's one more here, yes. There is C, and B, and A. How about we close the end and start in the beginning of each one of them and then generate a circular one? Well, let's go ahead. So here the first one will give me A, then B, then C. Yes, that's one. The second one will give me C, then A, then B. Yes, that's another one. So then this one, the third one will give me B, C, and A. This one will give me A, C, and B. How about that one? This will give me B, A, and then C. And the last one will give me C, B, and A. So when you do these things, first of all, you kind of think that, okay, so each one of the linear ones are going to give me a circular one. So they must have the same number of, we must have the same number of linear and circular permutations. But for a second, look at these guys that, let me delete these pieces here. Look at these guys that we have here. So A, the first three, and then the second three. You see, A, B, C, if we rotate, it's the same permutation, but I'm just rotating it. Circularly, these are the same thing. A, B, C. A, B, and then C. And well, if we rotate another time, so rotating, we see that all these guys are basically same circular permutation. So 3 of these guys gave us 1 A, B, and C. The other 3, you can again see that, okay, if I rotate, which way I should rotate? Yes. So I'm rotating this one the counterclockwise, yes. Then this one, 3, or sorry, maybe I should go this way to get a clockwise rotation. So all these 3 are basically same permutation, we just rotated them, so we shouldn't count them separately. But this one will give me A, C, and B here. What does this tells me? What it tells is that, well, the number of circular permutations is going to be very similar to the linear permutations, with one difference. We are going to overcount each one of these guys, each one of linear ones, 3 times here. In other words, so for this one, which gave us 1, we have 3 linear ones. For the second one, we have 3 linear ones. So each one gives us or comes from 3 different linear ones. So then it's like counting the number of ships, yes. You count the heads, the number of legs will be 4 times the number of heads, yes. So here the number of circular permutations of k objects is going to be number of the linear ones of k, but then you overcounting each one, you rotate this around the circle, so each one will give you k copies. So this is the general idea that you should keep it in mind. But when it comes to the specific formulas, we have 2 formulas. The formula one is that number of circular permutations of n objects. So you have n objects and you form a circle of n. This we know that the linear one will give us n factorial divided by n. So this will be n minus 1 factorial. So that's the one formula. How about number of circular permutations of k objects out of n objects, n distinct objects? So in that case, remember then in the linear case, we have n factorial over n minus k factorial. Then divide this by another number of objects on the circle. Okay, so maybe, yes, so the number of, which is k, yes. So that will give me n factorial over n minus k factorial divided by k. It's not divided by k factorial, so you should be careful there. Okay, so these 2 formulas you should keep in mind and use it when time comes. Okay, so let's do some example in how many ways a circle of 10 students can be formed at dance class with 10 students. So you have a circular dance, and then a dance circle you have, and then you want to put 10 students on the circle. So we know that this is equal to number of circular permutations of 10 objects. And by the formula that we had up there, it's going to be 10 minus 1 factorial, which is 9 factorial. So number of linear permutations is always bigger than number of circular ones. So we divide it, and that's how we get that. Let's do another example. In how many ways can a circle of 6 students can be formed? So in this case, we are looking for a number of circular permutations of 6 out of 10 objects. So that would be 10 factorial divided by 10 minus 6 factorial. So far, this is the linear one. Then you divide it by the number of objects on the circle. So this will give me 10 factorial divided by 4 factorial times 6. Let's do one more, a little bit more. So in how many ways can a circle of 6 students and another circle of 4 can be formed out of 10? Okay, so here then we have 2 steps. Step 1, we want to form a circle of 6 out of 10. Step 2, well, you have used 6 of a student, the remaining is 4 there, yes? So we want to form circle of 4 out of 4. The remaining 4, yes? So let me write remaining 4. So what do we do for this one? For the first step, so we have 10 objects divided by 10 minus 6 factorial. So this is number of the linear ones, but since we are on the circle, we have to divide it by the number of objects on the circle. For the step 2, there are 4 objects, and we want to put them on circle. How many ways we can do that? 4 minus 1 factorial. Okay, so this way we have the total number of the ways we can do that is 10 factorial over 4 factorial times 6 times 3 factorial. And as you can see, this 3 factorial is 6 will cancel with that, and that will give us really 10 factorial. 10 factorial divided by 4 factorial. So you should keep always in mind that when you're doing circular one, you're getting a little bit overcounting. That's why we have to divide whatever the number is by the number of objects on the circle.